Okay, we are live. Good morning, everyone, and
Good morning.
welcome to Swift Cairo. Today is a morning webinar and a special one, an excited one about system design. I am Hamad Nagar, co-founder of Swift Cairo, and it's great to have all you here tonight. And for those joining for us for the first time, Swift Cairo is a local community iOS iOS development in Egypt. We're passionate about bringing world-class iOS knowledge to developers right here in Cairo and Middle East. Our mission is to elevate the Swift and iOS development ecosystem in Egypt by connecting local talent with industry experts and cutting-edge practice. Today topics, it's really interesting topic for me and the community about the mobile system design, represent exactly what we are talking our taking our iOS development skills to next level, like moving beyond just not writing code or add some views to architecting robust, scalable mobile systems. I'm thrilled to introduce Tjeerd, a true pioneer in iOS and mobile development thinking with over 25 years of experience. Tjeerd has shaped mobile applications at some of the world's most demanding scales. He's been a staff engineer at Twitter, now X, where he took the challenge of building features for hundreds of millions of users. He also served as a mobile tech lead at ING International Bank, bringing his experts to crucial financial systems that require both performance and absolute reliability. He is a author of two essential books, Swift in Depth and Mobile System Design, which directly relate to the name of talks tonight, but he will represent something different, I guess. And yeah, please join me in welcoming Tjeerd and floor is yours. Welcome to
Oh, thank
Software.
you. Yeah, well, thanks everybody for joining. So yeah, no, yeah, I will start with today. My goal is to start with the presentation, and then basically the presentation is about like what is mobile system design, like how can it help you, and then the idea is then to get a briefing. So I will show a UI design and how I would basically approach turning this UI into an architecture. And I think when I give this kind of topic in workshops, people are quite surprised that my approach is quite different. Unless maybe if you already know my book, then you will not be. But it's maybe I think of an eye opener to some people to how they can sort of architect a whole system. But yeah, so it's about also like having fun to see how I would come up with something. Yeah, that's basically the idea. So let me
Yeah,
start with the presentation.
yeah, for sure.
Yeah, go here. Okay, so I want to talk about mobile system design. Like, what is it? Like, how does it help? You already gave me background information, so I'll keep it short. I wrote Swift in Depth and the mobile system design books. I worked at ING and Twitter. So I'm going to just skip because you already covered me here. So first of all, what is system design? And if you were to Google this, you would think this is like an interview step for backend developers, right? You would, for example, as a backend developer, I know this is a mobile talk, but as a backend developer, you would join or try to join a company. You get interviews, and one of the steps is an system design step. And you may get a question, like how would you design a chat service for 10,000 concurrent users? So what would happen then is you would prepare, and very common, you would come up to resources such as the pretty well-known System Design Interview book, which is a very back-end heavy focused, basically a book full of use cases on how to prepare with common scenarios and how to solve those in a system design kind of way. And ironically, mobile developers sometimes get a back-end system design interview a couple years ago because there was no such thing as mobile system design. So if that is system design, well, then what is mobile system design? And for me, it's not really that much different. You still get like a request to build something, right? Someone may ask you, instead of building a backend system for concurrent chat users, they may say, well, how would you build a chat client that stores a lot of messages locally, right? So it's more like a locally based feature set as a mobile engineer. But the idea is still similar, right? You need to figure something out. Another question might be like, how would you implement a third-party passport scanner for a travel app? Or how would you create an augmented reality layer for a museum store? So very different questions and some sort of open-ended, feature request that you need to figure out. That is what system design is about. And I would say, in a nutshell, it's about coming up with like a technical solution to satisfy the business requirements, right? Or you can say maybe think about, you design components and their APIs, like how they communicate with each other to solve a problem. Now, since we are talking about mobile, we have mobile-specific constraints. So a tricky one is always keeping the data in sync with the backend itself, maybe delivering components that are reusable because we are all working together in the same code base. So it is kind of an art to figure out what is very feature specific and what is a sort of reusable generic component. Keeping the binary size low is a common challenge. Dealing with very complex UIs and flows, that is always a very tricky one, because as soon as you have giant features, you get like, giant flows, which is a front end problem or a mobile problem as well. Then you have to integrate third-party SDKs because they ship with the app. You have to deal with them. And also they are not always stable or easy to use. Then there's the performance. But there's a lot of stuff, right, for a mobile developer to deal with. So this is kind of like the context of which we would work in the mobile development context. So let's talk about common challenges. One of them is we're always delivering one binary together, right? Unlike maybe microservice application, we can't just say we're just going to deploy one feature. We can't just say we're going to ship the settings screen. Like as a mobile developer, we have one screen, one binary, and all features are shipping together, whether you like it or not. So even if you maybe work for 3 months on this cool onboarding feature and someone else breaks like the login, well, now your build is it's the same build, so it's interrupted, right? You need to have a hot fix or like a new release. So that's really a real difficult challenge with a larger app and larger teams in mobile in mobile development. It also means you are always working with very much the same code base, right? We don't have separately deploying sort of servers that have their own programming languages. We are all basically creating, again, the one binary. So everything is packed into one thing. And that also means we have to figure out how to then share components. Like if I make like a UI library for other teams to use, right? That library better be really good, because if I like change a button, it may break someone else's feature. So you have a more of an interdependency kind of a situation with mobile development. And that is the next thing, right? You have, as you grow, your team will have like features and feature modules and then components, and they all start depending on each other. Now, mobile developers have this idea that if everything is then an interface, then that solves that problem. Not really, because in the end, everything has to ship together and has to be glued together. So it is just trickier for a team to be really autonomous. Like you just can't ship your own features separately. Now, another common problem or challenge maybe for mobile developers is there's external pressure. Like we can't just stay on all programming languages for years. Now we get, for example, annual platform updates. Like there's a ton of them. Just now we went to iOS 26. Whether we like it or not, we have to prepare for these updates, right? You have, Apple and Google, they are saying, look, there's a new update coming. Be sure to be ready. These are the changes. Watch all the videos. So even if you're already busy with just your own work delivering features, you're still dealing with this external like pressure. Like you must update everything. You must be up to date. And another challenge is that we have a lot of devices. Fragmentation is maybe a term more known with the Android world, but as iOS developers, I mean, we're not on the iPhone 4 anymore with just one size. We have a lot of sizes, a lot of screens, different devices, CarPlay, we just have a lot more different targets to work with. So like building on different devices, it's a more tricky to navigate this when mobile is so UI heavy, but then also you have all these different devices to build on. And then we have the programming language updates too. That's Apple saying like, cool, look, we got a sync await, we got these cool new features. That's all cool, but they do turn into warnings and errors in your project. So you have to update and you have to learn new things. You can't just be a backend developer that uses PHP for 20 years. No, you have to update. You have to stay up to date. And it's not a bad thing to be up to date all the time. I think that's important to do. But it is a lot of pressure to have to do this. You don't really have a choice. And yeah, sure, some people still use Objective-C and in iOS world, and that is totally fine. I actually worked on a project not that long ago that was Objective-C, but there's no denying that you will also have to keep updating your Swift code to the latest version, or else you're gonna run into issues later. And then there's the new paradigm shifts, right? We now go from UIKit to Swift UI, or Android developers go from XML to Jetpack Compose. So again, you don't have to migrate right away, but it is kind of expected, right? And especially if you're applying for jobs again, you can't say anymore like, oh, I don't know Swift UI. I prefer UIKit. No, you have to learn Swift UI now, and in some cases learn both. So there's that pressure too. And just this week, we have a new design language. We have the liquid glass. So and maybe you may say, oh, that's all fantastic, but as a developer, you're also like, now I have to make sure every screen that I made is now properly working with liquid glass. So it's just a lot of external pressure, just without us doing without us making sure our bosses and clients are happy. It's just Apple and Google being like, here's the latest stuff, and you have to just keep up to date. So that is very hard to do as a mobile developer to navigate this this tension. And then ironically, if the external pressures are not enough, we also have internal pressures in the community. We just argue all the time, or squabble, I should say, about like, what is better? Few models, MPC, you need directional data flows, clean architecture, TCA, Viper, model view. Like every day on LinkedIn, I see a post about how Swift UI should or should not use view models. We're still having that discussion. I think it's kind of funny. And as I want to show you is that it's actually not as important as you think. Like I want to show soon how the UI and the patterns are not as like super important as people really want to believe it is. And on top of the patterns that we as a community sort of decide upon and what businesses hire for, like you must know this pattern to work in our code base. You also have the paradigms, right? Like Swift is known for being a mixture of a lot of paradigms. It has functional programming in it. It has imperative programming. Now with Swift UI, it's more pushing towards declarative programming. But there's also a component of reactive programming. There's also the combined aspect that is now also being embedded. And Swift uniquely has protocol-oriented programming. So there's a lot of these paradigms. And if you're just learning programming in your first years, I feel like it's kind of like a lot that's like dumped on you. Like you gotta learn the imperative and the functional and the declarative. It's a lot of paradigms to work with. And I think that's kind of tricky as a developer because yes, Apple shows you like, look, Swift UI, just put in the text and the image and the label and you have a view. And I think that is a nice start. But once you really go into like a fully mature application, you do have to know about more things. Like especially if you join a large company, you will see a mixture. Like some modules may be built more like with the functional aspect in mind, and others may build more like with the reactive code base. So these are just paradigms you just have to deal with and also learn on top of all the other things. And to make it even worse, we also are now figuring out multi-platform, right? I mean, it's been trying to be figured out for years, and with trying, I mean, there's not one solution. There are multiple very valid solutions. But it is moving, and the goal of multi-platform often is costs, right? Saving costs. Like businesses, they want to build once and deploy twice, or as I sometimes say, build once and debug twice, because it's not as simple as it seems. Like it is kind of romantic that there's one solution that works for both platforms perfectly all the time. But of course, there are really good solutions that get you really far. I'm hearing great things about Kotlin multi-platform, for example, and also mixed things about React Native. And now we have the Swift Android work group from the Skip guys. So there's a lot of stuff happening. Also, what I personally really like is service-driven UI to get that more figured out. I think there's not a full standard yet, but I think that is also a very interesting way to approach being able to deploy features that are working well. The backend can decide how the UI looks. That allows for a lot of flexibility. And I haven't even talked about, your own business, really. Your boss or your manager or your client, they do want you to change things and to come up with new features. I mean, that is why we're hired, right? We are here to build features and to help users with something to increase some sort of value for the company. So that's kind of the joke here. Is like, yeah, we want to release something, but we have so much external pressure, and also in the community, the pressure of how we should work and how we should stay up to date. So for me, mobile development is not just making a couple of views. It's really about keeping an app really maintained well and up to date well, and handling changes and dealing with the flexibility that offering flexibility to deal with all these changes. So to bring it back to why mobile system design is important again, well, software is expensive, right? If we just are working all the time on keeping our app alive with a ton of developers, it's not cheap. That is a reason to figure out a way to deliver apps in a way that can be adapted quicker and be maintained easier. Staying nimble or agile is very important, right? We have a lot of changes always. So, even from Swift UI kit to Swift UI, now to Liquid Glass, that's a very UI focused change. These changes are always coming, right? And then as a community, we may decide, a few models are outdated now, so now let's use a new sort of acronym, MVPQS, whatever we come up with, that will then require a migration. So how can we handle all this while not losing a lot of speed, right? We're constantly in flux, in changing things. Also, what we want to avoid is as software terms call it, the big ball of mud, where it's just like a messy code base, or a spaghetti code base, some people call it. Where you have a code base with a lack of structure. There's no design, there's no plan. People just get started, they just build stuff, right? And then deal with problems later reactively. Maybe people are also not really accepting change. They just kind of stagnate. That's also a problem. You got to be able to change, as we just covered. There's also the technical debt aspect. So if you just build features and don't really think about an architecture or a plan, then you will accumulate technical debt. So then that means you need to have a migration, or like get rid of features and rewrite features. I've been in plenty of situations where people were afraid to touch code because it wasn't tested and it was very important and it was everywhere, but people were too afraid to change it. So also creates some kind of fear, which is also a problem. Just making it hard to maintain the code base is also really difficult. Like I said, if people are afraid to change things, or if you change something and it breaks everything, that's just a very difficult situation to be in. That's something you should try to avoid. Another reason you want to have a good design is you don't want to be so susceptible to trends, right? Like I said, like we go from MVC to MVVM, and then people say, no, reactive is the future. And then people say, declarative is now the future. I've been in this industry, I think, since 2010, this specific mobile industry, and there's always something. And I think if you're in there long enough, you start to see it's just the same rhythm. It's like something gets introduced, the community is like, yeah, this is what we should do. And then everybody sort of migrates their code base, and then the next thing comes, and then the next thing. So what I'm trying to teach is how you can just accept this fact that people will change architectures, and Apple and Google will come up with new things for you, and then figure out a way to not be so susceptible, so you just can keep your speed and keep moving forward without being like put in a situation where you have a giant rewrite for your application just because there's a new pattern or architecture. And I think very important, focusing on the right things is really crucial, because I think a lot of developers, they sort of get distracted by the details. They get like a screen and they start making the prettiest buttons and the prettiest animations, but then at the end they start integrating with the backend API and realize there's actually not a good system in place there. Like, it's very difficult as a software developer to know what you should focus on. It's very easy to see in hindsight, like, oh, I shouldn't have made this, I should have made the other thing. But I think navigating this becomes really important. And it's something I really want, like teaching people, is how can you move forward without knowing everything that you know? Like, how can you deliver something without having all the requirements in place? Like, you still need to move forward somehow, but how? How would you do this? Or you don't know everything. You don't know all the specs. So what do you build? So I think that's really, yeah, an important part. So then, well, how can mobile system design then help you in your day-to-day work? Well, first of all, yeah, you keep your focus. Stop being distracted by the latest shiny architectures and the UI stuff. I want you to learn that it's okay to have a stable foundation that is very strong in adapting to UI changes or updating features quicker, right? New change comes, we're moving to Swift UI, we're moving to a new pattern, we're having new business requirements. Well, it's not as much of a pain if you really have a good design. Easier said than done, but it does help to think about a good design. As I mentioned before, you want to have component reuse in a mobile application because we cannot ship stuff independently. We have shared libraries we depend on, like shared UI libraries, or even technical components, like maybe analytics or a networking module, right? So we want to be able to deliver components that other developers use, and it speeds up their work. And then if you debug something on the component, then everyone's feature has the bug fix in it, right? As opposed to a lot of duplication. You want to be able to support a lot of targets, a lot of platforms, right? If Apple comes up with new things, like just now the headset, but maybe another thing comes, well, we are ready. That's important. I talked a little bit about how some developers wanted interfaces to have a lot of autonomy. And I think that is kind of the real wish that developers have, is where they can build something in isolation for their feature and then put it in the app and it just works, right? Not have some other team build something and it kind of becomes like a spaghetti code. So it's less about having a monolithic experience and more about a more modular experience, or maybe better domain modeling without having modules even, that also allows teams to work more independently. That is really an important goal that a lot of developers have. And I think that is maybe what developers truly want without saying it. They say, I want interfaces, but what they're really saying is, I want autonomy. And I think very, very important is, how do you move forward without knowing what you have to build? I already mentioned this earlier. But yeah, you have unknowns, you have, some requirements, but the full requirement list is the code, right? So there's a gap between getting design and a couple of wishes and a full-on like application. And there's a lot of unknowns for you to figure out. So how can you move forward with that? That's important. My favorite is not so much adding features, but deleting stuff. Like, it's very satisfying to have a pull request with just a lot of deleted code. So that is really tricky to do if you have a feature that's entangled everywhere. So how can you do this? How can you swap code more easily? And how can you design things in a sort of domain modeling kind of way so that you can take out an entire domain without everything being, sort of obstructed and like entangled with your code? That's also an important aspect. Testing, common topic. Not everybody tests. Some people test a lot. Some people test the wrong things. Some people test the right things. Some people overly test everything, or test things that are already tested. So figuring out what to test is quite tricky. And I think with a good system, with a good design, you can have these good seams and APIs between domains that allow you to better test each domain. You also want to keep your architecture simple, right? Plenty of teams I hear that are struggling because they have just built layers and layers of abstraction. They have some sort of presenter on top of a sort of business logic, on top of some router, on top of some other thing, where just a few that makes a network call is enough, right? So figuring out how to keep your code simple is also more pleasant to work in. And finally, you want to have an easier time to maintain and a cheaper time to maintain your code base, because, like I said, there are a ton of updates that are coming your way, whether you like it or not. You're gonna have a new iOS update, a new Android update if you're an Android developer. You're gonna have new UI updates. Just now this week, right? Just proves my point. There's going to be new pattern view models are going to be outdated sometime, or someone on LinkedIn will say they should not be used. There's just going to be new stuff, so you got to be ready, and that's why you want to make it easier for yourself to maintain your code base. Yeah, so that is my intro. What I recommend do now is I want to show you how I would take a screen and also figure out like how I would model something. And first I want to show you how other people usually model something, and then I want to show you maybe slightly different way that could hopefully help you. Let me start with the design that I got here. And again, it's not again, but like this is like an idea, right? You don't have to work completely differently because I show you a different way. It's just like a suggestion. So the app design that I want to share with you it's already outdated because it's not liquid glass. It's kind of like an itinerary, like a trip, like a tour guide, which is sort of a smart screen. So it would help you with a day trip really, and show you where to go, what to prepare, like how to get there. It's kind of smarter than just a Google Maps kind of a plan. So for example, it's aware that there's like a storm coming, so you may want to change something. So where you need some sort of preparations, maybe some linking. Then there's the itinerary itself. So it shows you where, this is grayed out. So it shows you this is where you're at now with the green ball. How to get there, and it is also aware of you need to book time slots and maybe changing plans because of the storm. Maybe charge if you have an electric vehicle, you got to charge it. So it's aware of traffic and also aware of more preparations you need to do. So let me open a drawing tool. There we go. I have it in this drawing tool. I use Xcala Draw, but you can just use whatever you want. You can even draw it out on paper if you want. So most people, this is also how it used to work, is they would see this screen and they would really think in the UI terms, right? So they would maybe say like, I have like, what's it called? Like an itinerary view, right? And they would start this way, and they would, actually, let's make this large. I'm just gonna move it this way. Don't edit text, because then I have more room. And they would think maybe they need some sort of view model, and they would think like I have like a preparations view, and it's basically they see the UI, and they're really gonna cut it up, right? So and then there's like maybe this would be the itinerary view, and then maybe this should be the day trip. And then this should be the day trip view model. And then they will connect this. And then there will be maybe, I see here, like a map view. So there's a map. So they would add that. So let me just quickly add this. Oops, there's some sort of map view going on. Basically, they would really think about like, okay, what do I see here? Like I have like some sort of like a day trip cell. I know cell's a bit of outdated term nowadays, but I'm going to use it because I think it's fine for now. Day trip cell. And it's really about sketching it, right? It's about figuring out, okay, what kind of stuff do I need to get this working? Most people would also think about like, okay, I need some sort of networking. So they have like maybe as a day trip API, and that maybe uses like a network API for like the general networking. Yeah, I think this is already becoming some sort of architecture. Some case they will think about, okay, where am I going to add my interfaces, right? So they may have like, they may say like, I would actually want to swap out my API part. So they may have like a day trip API interface or protocol, right? So they will add that. And they would kind of like design the application this way. And in some cases, people, yeah, they skip the design and they would just get started, right? They would just go in the editor and just start programming. Um, of course, drawing something I think is already a good idea if you're working in a team, not alone. But I think usually it goes kind of this kind of direction. They look at all the UI, they think about the stuff I need. Maybe they think about like a flow because this is a part of a vacation. So they may think about like, oh, maybe I have like a vacation flow, and then they would draw kind of like this, and they're like, okay, yeah, this is good enough, and I can start my my work, and they're gonna open the editor and basically begin. What I want to show you is how I would approach this, which is a bit different. Yeah, so this approach is what I used to do, what I see many people do, but I want to take a little bit of a different approach. So first of all, I wouldn't even start with the diagrams. I would think about just the specs, and I think about it very vaguely. So I see some questions coming up. Who's responsible for system design? So I think any engineer that is building their feature can come up with their own design, right? Like if you work in a feature team, let's say you have a feature module, you could say, like as a feature team, you're gonna design our own feature module this way. Like it depends on your team, of course, but yeah, if you're the owner of a feature, you are also the owner of how you're building it. That's the goal, right? Also, an interviewer, you get like a feature to design. Well, you have to figure that out, and in real life, you would also implement it. But this is sort of a prerequisite step. But to go back to the design, I would first think about kind of the vague terms, like some sort of what do we need? Well, I see we have some sort of preparation. We have some sort of like itinerary, right? And I would really try to uncover the secondary and the non-functional requirements here. So we have some sort of itinerary, but if I look at the itinerary, it's not really just the list. It has some sort of route planner inside, right? Some sort of route planner, and it has some sort of, I don't know, some sort of restaurant system. I don't know the names yet, but this is kind of what I do see. We need something like this, right? Oh, my icons came in. Okay, so and let me see. We have like the attractions, right? Because we're visiting a museum, and we're at the lunch, so we have some sort of attractions to go to. I also realized that there is like it's kind of aware of hazards. So it is like maybe there's like a sort of protection mechanism that has like hazards, and also it knows like how long you have to walk. So maybe it can figure out like, oh, maybe it knows like delays, right? And what I'm doing here is I'm not even thinking about like UI. I'm not thinking about like interfaces and like which classes and structs I'm building. I'm just thinking vaguely about like, yeah, what do we need? So for example, we have this like route, this as part of the attractions. So we have this sort of like route planner, but I noticed it has some sort of EV charge awareness. But there's also a question I get. It's like, okay, if it knows about charging, but does it know about gas stations? And maybe what I can do as well is I have questions for my customer, client, whoever wants to build this. So I will also have these like requirement questions that they did not give me, right? So like, do we need gas station support? EV charge, do we need to know which plugs are supported because you have different plugs for the cars, right? You don't want to have like you don't want to have the wrong charge plug and then not being able to charge your car. Speaking of experience. So yeah, you're just trying to figure that out, right? Let's see. I also wrote down some notes to make sure I didn't forget anything. Yeah, there's like so like the non-functional requirements. So what is not given to us, yet what can we try and figure out? So I think, for example, deep linking is an interesting one. Like, do we want to be able to have a notification and then instantly go to this screen? That's something I don't see in here. So but it might be really important, right? You may get like a pop-up on your phone. You're like, look, you're behind on your schedule, so make sure you leave soon, otherwise you're gonna miss the next step in your itinerary. So that is also a question I have. Do we need like deep linking, right? Does it also mean like notifications? Let's see. We can also think about components, like are there components that are already available? Like you can ask teams, let's say you join a company and you get this screen, well, maybe other teams have made something similar. So like, are there any available components that we need to figure out? Again, it's just plain text. I'm not even doing anything with like views and UI. I'm just thinking about any text. Also, what I'm wondering is we have this this sort of like address aware, like map aware system. Do we need to use SDKs? Like, will we build it ourselves, or will we use SDKs for the map and for traffic? Most likely, but yeah, again, is it mentioned, right? We just get this get this request. So I think I would have like a plan. So because this is a presentation, I'm going to keep it short. But like normally I would spend a bit more time figuring out like, okay, what are the requirements that are not really that obvious? Like, yeah, it's obvious we have like a list here, and it's obvious we have a list here, but like there's stuff hidden in here, right? So let's see the question. These are assumptions. Yeah, so we have assumptions, but the assumptions turn into questions for the person that wants us to build this. So these are questions we can give back. And yeah, and maybe also other questions we can come up with, like, is it the iPhone only, or is it also tablets? Like, there are more questions we can come up with. But what I would do now as the next step is I have figured out already a bit more. Like before, I would have a strong UI focus. But what I would do now is figure out, like, okay, look at what I figured out. Like, I have these sort of systems, and how would this turn into an application? So now I
I
would
have a
start
question
sketching.
here. I
Oh
have a
yeah, sure.
question here. It's related to what we are doing now. This questions is the questions here is mean our assumptions, right?
Yeah, so the questions are assumptions that we have where we think we need this indeed, but they turn into real questions for the person that gives us this briefing. So if you're interviewing, or or you have a customer, or your boss asks you, or designer gives it to you, they may be like, "Can you build this?" And you're like, "Yeah, sure." And then by really thinking about how you use the screen and thinking about what is hidden, you get these questions, and you can move forward with assumptions. But then I would not move forward with assumptions. I would try figuring out what are the real answers, right? Because if you just assume it's going to be a Google Maps SDK, and then someone else says no, that was not. We don't want that. You have a problem. So,
Yeah.
but you can. But what you're doing here, if let's say a designer gives you this screen, you're also educating them on the feature, because you think about different things. They think about the user is going to the screen, and it knows where it is, and it has the green marker. But you may think about um, like how would you how would the screen break? Like, for example, let's say I'm delayed, right? Now I
Yeah.
need maybe a notification, and the designer may not have thought about this. So what happens is you are educating them to also think about the problem more deeply, and then they will also give more answers to your questions. So they may say like, yeah, if you're delayed, we now need push notifications. You're like, okay, well, now I know I have push notification support. That was not clear at all. And if I just started building, that would have bitten me in the development. But now I know. Now I can plan it. Now I can tell the customer, like, it's more expensive because you want more features. Now you need deep linking, right? Because if the push comes in, you need to be able to have your apps swap. So these are secondary requirements, or yeah, as the Tjeerd agrees, it's like non-functional requirements. That is irrelevant. Yeah, that's a good point. We need a section for requirements for optimization and battery. Yeah, that is also important. Like, how would you like we have to figure that out, like, right? How do we keep battery usage low? Like maybe well, let's ask if that's a real requirement. Maybe first version, battery usage is not important until we ship. Maybe it's first important, we just ship. We're a startup, we have no money, we have no time, we ship. Um, how important is this, right? So these are the questions that are coming up. But I think that's a good question because if, again, my point is, if you just start building, you don't really think about this. And I just took like, what, 10 minutes? I already uncovered so much more. But many developers I know, they just open Xcode and they just and then they're like, oh crap, I need deep linking, right? And then it's like 1 week before launch. So it's and that's what I'm trying to avoid. It's cheaper to think about these things while you're just writing it in plain text. Really, that's really the message here. So the next thing I would do, I see you don't have demo times, I'm going to hurry up a little, is I would turn this into an architecture, like a sketch of the architecture. So that is the system design part. So for example, well, let me first get I have like a legend somewhere. Where is it? Here. One approach I use, let me move it. I have stuff that I sort of decomposed and figured out, and stuff I have not yet decomposed and figured out. So I see I have some sort of day trip or like an itinerary. Let me start with that. And let me make it, I have a dash because I have no idea yet how this works, right? I have some sort of idea what's in there, but I can decompose it. So I can say, the itinerary consists out of a route planner of some sort. I have some sort of restaurants system. I'm not really sure yet the name, but that's fine because I'm not setting it in stone. I'm sort of sketching out the names. I have some sort of attractions system, and I have a protection system. Right, this protection system makes sure that if I am not didn't book a time slot, or if I'm not prepared, or if there's a weather issue, it protects my day to make sure I have a good day. It comes with alternatives maybe. So what I do at this stage, I can be like, okay, this itinerary depends on these systems. So I'm just decomposing it into smaller systems. Let me quickly add the arrows. Then I can say this thing is decomposed enough. So I mark it as just a regular line. That means that even in code, I could already define the itinerary class, I think it should be a class. I could already write the itinerary class, and then internally it has all these dependencies on the route planner and restaurants, attractions, and protection system, and those are not figured out yet. But I can already write, in code. I could, pretend I'm using it, right? I can be like, itinerary is itinerary, and then say like in itinerary, give me the what is it? Give me the steps, right? So it will be like itinerary steps, like all steps is itinerary steps, and this I can already start designing as an API for the itinerary without figuring out anything else. So, and then I repeat the approach. I can say, you know what, protections. Let me take that one. So protections is, I need to figure this out. So I know it has some sort of like hazard system, and I know it has some sort of this hazard system maybe has some sort of weather system. I don't know yet how it works. Again, that's kind of the point. I don't know how it works. The protection system also has some sort of like I don't know, like preparations, because it says like, did you book a time slot, or did you change plans? Oh yeah, change plans. So it needs alternatives, I realize. So let me draw this. It needs some sort of alternative system, right? That's uncovered. Let's see, it had some preparation I just mentioned. So it has some sort of preparations that it needs to be aware of. And again, I have no idea how this is going to be built or how this works, but I do know it needs it. And oh, that's actually the wrong one. And again, I have this all marked as dashed because I don't know how it works, but I do know protection system. I feel confident enough that this is decomposed enough. Like if I were to write, let protection, I mean, a day protector in my code, right? Is protection system. I would, I'm sketching here, but I would know day protector. I would know like fetch maybe alternatives or something. I can design the API. I know it needs alternatives, right? And once you start really, really implementing, of course, you're gonna need some sort of ID, and you have the dependencies. I understand that, but it allows you to already come up with this very sketch based approach. It allows you to work very quickly to come up with a sort of skeleton for your entire architecture. And what's interesting about this is you start uncovering these kind of domains. Let me see if I can move this a bit. So this becomes its own domain. These things, they start to emerge. So now we have this sort of protection domain. So we're actually domain modeling now, right? Because we realize like, hey, we have a collection. We see these things go together. So this could be its own domain. And sometimes you can even already go and make this a module. Some people really like making module front. I would say design the APIs, design the domains, and just put it in one file. It's really small. It's all sketchy, sketching. But then once it starts maturing, you get a lot of classes, a lot of structs, a lot of files. Then you can figure out, okay, now is a good time to extract this to a module. But at this stage, you're still it's such like a iterative sketching kind of momentum. I would say keep it all together and really make sure you focus on the strong like APIs. You really design these APIs, because if you figure out these APIs really well, then anything underwater can change much easier. But first, if we change this the whole time, well, then we have to keep updating other code. So that's kind of approach that I like to take. And you just keep on decomposing, right? So if you want maybe the weather, you're like, okay, I actually want to work on the weather part. Well, I'm going to figure out, okay, we maybe need a weather SDK. Maybe we need like, I don't know, storm tracker. I'm just coming up with like these terms. And actually making this the wrong style. Now we can say the weather is decomposed enough, because this is enough to work in. So you can take bits and pieces and just keep making the problem smaller, smaller, smaller. And what people then usually see here is this is becoming like a real architecture, right? I'm not really following a pre-made architecture. I'm just figuring out my own architecture. What is noticeable here is none of this is UI. So this is the data part. I haven't even thought about UI, and that is kind of the goal I want to tell people is we're building a full-on application, and yet we get UI, but the UI is sort of the window of which you look to find a full application. So we could have a placeholder UI. That is something I do like to recommend, is you have some sort of, let me say, day trip view. But again, it's not figured out. Like, I haven't had discussions about why we should use Viper versus view models versus TCA versus whatever. I'm not even thinking about that. I'm just thinking, I want a full-blown application, and I just keep decomposing, designing the APIs, finding the domains, figuring out how to glue it all together. And if you give me 1 more hour, it would have been like pretty substantial part. Then you can also figure out, okay, I want maybe let me add developers. Let's make them ninjas, because ninjas are cool. So you can say, one developer, that's really large. So one developer will focus on the UI part with maybe a good API. sorry, I already have the API. And one developer maybe works on like maybe this protection system, right? So you can easily divide and conquer the systems you want to build with developers, and they kind of stay out of each other's way. Versus before, if you just start and just one person just makes a few model out of the list, and they have to like communicate a lot more. Versus this way, you can sort of be like, you do your thing, I do my thing, and with the good API design and the good knowledge of which domains we are building, we can work more in isolation. I think that is kind of a very different approach. What I also notice here is if this is all well designed, this itinerary becomes very simple, because if all of this is working really well, imagine a couple hours later, you have like the full restaurants and the attractions and the route plan all like decomposed. It all turns into the simple list. And I think that's kind of the tricky part of mobile is usually most things are lists, right? Mail is a list, the tabs you have open is the list. Things are just lists and cards, but that's the seemingly tricky part, because yes, it's just a list, but it's a very smart list running on a quite complicated application, because figuring all this stuff out with the whole itinerary and the route planner and the restaurant planner and the attractions and the preparations is a full-blown application. But we just see the list, so it's deceptive in that sense. But by building this application, the step between day trip view and the itinerary, that will still be just a list, right? The day trip view may say, just give me the steps. And the itinerary is like, okay, here they are, not knowing, for day trip, not knowing that actually a lot happened, right? It called like all these backends, all these network calls, etc., to figure this out. I guess that's also a good point. I haven't even talked about networking yet, but we can imagine that there's a networking component missing. Let's make a network API. You can also start at the bottom. Sometimes you don't always have to work top down. If there's some sort of networking API, again, I haven't figured it out. Maybe we need another developer for this. But we do know we need it, and we do know maybe the storm tracker needs it, right? We do know maybe maybe the alternatives part needs it. We can create all these connections, and again, this can also turn into its own domain. It probably will be, because from experience we can say networking is its own domain, maybe even a module, and we just keep on going. So I guess what now becomes more clear is that the application again is underwater under the UI. And this also gives you some flexibility, right? Because the application is gonna be like, I don't know, 80% here, whereas the previous approach would have been 80% here. But now it's all 80% data with just the list and just a couple of views. It makes it much simpler to change this view, or to, I don't know, if I have a UI kit view, I can add it, right? Or I can even have new targets, right? I can have, I maybe have a watch app, let's make targets green. I have like a iPhone app, right? iOS app. I may have, I have iPad OS, I have iPad OS. But also what you can consider now, some people don't know this really, but you can make a headless client easier. So headless clients are just basically a command line tool that just use the code, and you can, for example, make network calls, right? You can run stuff from the command line. And I think by keeping it more like heavy on the data layer versus heavy on the UI layer, you create an application that's easier to test, easier to support multiple targets, easier to support multiple formats. Basically, I'm thinking of this application as a command line tool that just happens to have a thin layer for the UI. And this makes it a bit easier for me to adapt. Of course, UI can get complicated. We can have like a giant flow with a lot of branching. Absolutely. But I do think the connection between this and this part becomes very small. I think that's kind of the key takeaway I want to give. And one more thing I want to share. We have another sort of division and that is the backend itself. So we have the backend, right? We have backend devs in the backend. And also here we have, make it orange because it's going outside the app domain. Also here we have some sort of, like some sort of networking you have to figure out. It's a bit hard to see maybe with orange, but what I also notice people do is they really stay in the UI and they start making the buttons and the lists and I get it because it's the most exciting part, right? They receive the screens and they want to make the screen, and then once the screen is looking nice, then they want to really make it work. But the problem with that is that you're kind of working in your own bubble with not a lot of communication with your coworkers. You can just start. Versus if you were a developer and you were working here, you already can figure out how to integrate with the backend, even with just a placeholder UI, placeholder views. You can already figure out like, hey, the API calls you said were working, they're actually not working. Or they're broken, or it doesn't have these errors, or the errors are not documented. So you work more on integrating. I think that has a higher priority because if you detect an issue, the backend developer has then time to fix it early in the process versus if you wait a long time and then notice the issues, now you have more risk of delays. So I would try and find integration points between teams and figure those out first. So in this case, backend is the classic example because yes, you need to talk to the backend. But maybe a more subtle example is maybe this integration. Maybe there's a developer here and maybe a developer here, and maybe it's more important these two figure out the API together than it is to just be in your views and make the list shadows look nice, right? Figure out these integrations. I recommend to use a placeholder. And continue from there. Yeah, I think we're out of time. So, the next steps will be testing, modules, scaling. I see a mention of a dependency container. Yeah, so people at this point start thinking about, okay, how about dependencies, what to inject? I think that is the next logical step.
Yeah,
I think
sorry for
this
interrupting you. You can take your time. It's fine. We already
yeah, no,
recorded the session, so it's fine. You,
yeah, no, I think I already said what I wanted to share. I think if there's one message I want to say is really figure out the requirements and draw them as an application, not bound by UI. Like we get UI, but see the UI as like the tip of the iceberg. Like if you look at it this way, this is the iceberg, right? Let's make it blue because it's cold. Um, and then here's the water, right? We see the view, but really what's happening is a lot of this, right? And developers start here often. I say no, start here, figure this out. This is the view application. Pretend it is a Mac or a command line tool application. And I think if I can give you that advice, then I think I completed my mission today.
yeah, I got the point.
Thank
Yeah,
you.
that makes sense.
Yeah, so that was it. I think. Any questions?
Yeah, we already have a question related to like it's sometimes depend on time knowledge. Like to have a skill to do diagrams or just not building the UI, and that's why I know it will depend on time knowledge, and that's why I think we have another question about who is responsible for system design,
Yeah,
seniors
I did
or
answer that one earlier, but yeah, like I said, if you are in charge of building a feature, you can design. You don't have to open Xcode and start typing. You can sketch, right? Can you just get a pen and paper
yeah,
and start? And especially, yeah, if you're alone, maybe it's. Well, I do think, like you saw my process, like my thinking. I purposely did not rehearse it that much because you see me going all over the place. Like, oh yeah, maybe the weather system, maybe this system. If I were to just type class itinerary, I'm thinking like inits, what I'm gonna pass, and I don't know. I'm more like what I'm gonna name my variables, but like it's already so detailed. And what I want to show you, like if you start drawing, you just are your mind is working to complete the picture. And I think, yeah, you are responsible for the feature. Now, of course, if you're in the bigger ecosystem at the team and there's like a more senior developer that is really like bossing people around, they have their own domains. They may have the networking domain as their domain, but then this is that this is the developer that is he lives here, right? You maybe don't want to work here, but this part is all your domain. You are coming up with the design. You are coming up with, no, I need itinerary class and a route planner and a restaurant and an attractions type and then the protection system and a weather. And um, and what you see is you also uncover these secondary requirements. Like later I realized, like, oh wait, I may need a weather SDK. I didn't think about that before. Oh, how expensive is that? Now that becomes, oh, a question like, oh, excuse me, I have a question. We need to talk about finances and keeping a weather SDK alive versus, again, just starting and then not realizing it yet. So you are in charge of your own features, I would say.
Yeah, exactly. And yeah, that's the main. I can add a point here. You can working be a solo or working on something project with like there is no more capacity in the team. Maybe one engineer, two engineer. So trying to follow the same approach because this is a skill. It will be going on time. In every feature, you will write a lot of sketch. You will have a lot of errors. You will fix it and know what's best. What is the defective here? It's like when using Git. If you are working alone, you didn't use Git Flow, but I recommend everyone to use it because he is practicing. When you join the team, you already practice a lot of solid skills related to how to communicate with the team about this.
Yeah,
Uh, yeah, I
I
think
see.
there's another question related to. Yeah, yeah, I'm with you. If you have.
Yeah, so if this high level diagram, yeah, I would say so. I think if I would to keep working on this, it becomes more and more like the actual complete architecture. But of course, things are not complete. I don't have data models defined. I don't have interfaces defined. I don't have dependency injection defined. But what I do in code, this is also what I show in my book and stuff, is I would use this to define the main boundaries between each domain. So the
Exactly.
protection system is then the public API of this entire domain, right? So it's on top. That's how you can tell. It's the most important part. It's what itinerary would underwater. If I go here and say I have class itinerary, it would have let protection system inside, right? And it would not know how protection system does all this. In fact, this is going to change a lot. Like over time, new models, deleting stuff, renaming, whatever. But if we make the API stable enough, we think about how we want to use it, then that is the most important part. And then yes, it's high level because I haven't figured out 500 little models and interfaces, but that's maybe a detail, I would say. Yeah. And then maybe the next point is then, well, how do you know when you're done? Because you can keep going and make it complete and complete and complete. At one point you do want to build. And I think if you're feeling confident enough about a domain, you can start integrating it, right? Like I would feel confident enough to define the protection system. So I can already make this. I can already start with this, right? It's very simple class, but I may not feel confident enough about the weather SDK. But maybe I can already work on hazard. Uh, and it's about figuring, yeah, the goal is more to communicate what is needed. The goal is not to be 100% complete, right? If I make a user model, like a user here, yeah, maybe it's needed, maybe not, but it's not gonna completely change the system. So it's more about being able to get all the edge cases and non-functional requirements and out of your head and have a plan to continue.
Yeah, totally makes sense. It's not like just in real work you don't need, you need hours to build something like this, and not in a talk. And yeah, related to the book, thank you so much for your
Hey,
discount
you're
code.
welcome.
I already posted on the chat. If you are
Oh yeah.
in original, like for example in Egypt, you will get 50%. Use the code, you will appear in the website. But if you are outside Egypt, you can use the code. I will post it in. It's a Swift Cairo member, so you can use it. It will be 20% off. And yeah, thanks so much, Jit, for
Yeah, thank
this
you so much for having me.
interesting topic. I know we need much time for this, and I
Yeah,
highly
it's a good
recommend
intro.
to have a workshop about this. Let's like prepare some stuff related to this.
Yeah,
And yeah, thank you all for watching us, and I hope you really enjoyed with this. A lot of architecture, a lot of
yeah, I
diagrams.
hope
I
you
really,
enjoyed it.
yeah. Thank you, Tjeerd, and have a nice
Okay,
day.
thank you. Okay,
Bye
bye
bye.
bye.